My name is Corey Woodine. Today, my partners Amy Storrs and Tyler Tucker and I are going to be going over Chapter 13, Architect for Low Risk Releases. First, we're going to go over how to create an architecture that enables productivity, testability, and safety. Next, an architectural archetypes of monoliths versus microservices. After, we're going to go over the case study of evolutionary architecture at Amazon. And last, how to use the Strinkler application pattern to safely evolve our enterprise architecture. Now first, we're going to go over Google Cloud Data Store. As we see, Google is one of those companies that has grown over its life cycle. Google is now on its fifth rewrite of its architecture, only because it is expanding its products and application services. As you can notice, Google is inside almost, if not every home in the country and other countries. They have smart home devices, network devices, cell phones, and internet applications that serve everyone's needs and purposes. Now, Google Cloud Data Store is an application that is ran by a small team. The only reason that this small team is able to cover such an important application is because it functions on a smooth and operable architecture. There's many examples of architectures out there that are similar to Google Cloud Data Store, but this one is the best. This type of architecture has served Google extremely well. It functions applications such as Gmail and other important everyday applications that are used by its consumers. Each service is supported by a small team who builds and runs their functionality, with each group potentially making different technology choices. Now, this type of program has been perfected, and Google has paid its money to perfect it. Next, I'm going to pass over architectural archetypes and monoliths and microservices to Amy Storrs, and she's going to continue with that. Go ahead, Amy, take it away.
Thanks, Corey. As we look to the architectural archetypes, let's look at the monolith versus the microservices. Many of the large companies of today actually started off with the monolithic traditional model. So all the functionality, it was in one application. It made it so that they were self-contained and interconnected, so all the components were interdependent on each other. This was great. It was very successful. But as the companies looked to evolve the system, they weren't able to do that with this traditional model. So they actually looked and evaluated, and most moved to the microservices model because they could independently have teams building code and sometimes coding in different languages and have all of it work and be continuously evolving. So it made it so that it was it was independent, and it had large scaling abilities. Because really what worked in the beginning rarely works when you move to a much larger model. So by looking to support a architecture that would allow for this evolution, they would always know that there was the needs of the company and the business needs could be fulfilled. So a perfect case study on this is actually Amazon. They started off with a monolithic two-tier traditional model. Obidus was the name of it, and it held all their business logic. But when they went to evolve and to build and make all of their services go faster and have more of a searching capability and all the things that their customers wanted, they realized it had become so complex that it could no longer evolve and get better. So they looked and they actually decided to move to the service-oriented architecture. And by doing this, while it took them a long time to fully make the move, over time they realized that they were making more deployments a day. In 2011, they were at 15,000 deployments a day. And in 2015, they were up to 136,000 deployments a day. So they were able to rapidly move with the needs of the customers in order to grow the company. And through this, they also learned multiple lessons. They're looking to see that when they achieved this isolation of each of the dependent pieces, that they had a level of control that they just had not previously had. So it gave them more abilities for what they were looking to do. And by prohibiting their databases from being accessed directly, then they were able to scale things and make the reliability so much better so that they were never having an outage for their clients. And they also learned that the development and operational processes greatly benefited by switching to the service-oriented architecture. So in looking at all that, we see some of the benefits that this microservices can offer. And next, we're going to let Tyler take us over and talk about the Strangler application pattern. Thanks, Tyler.
Next, we have use the Strangler application pattern to safely evolve our enterprise architecture. So the guy, Martin Fowler, went to Australia and saw these vines in the forest that would start at the top of the tree and work their way all the way down and then root in the soil and grow strong and grow together. But in the process, they would also kill the tree that they started with. This turned into a parable and an analogy for the Strangler application pattern, which is, in this case, the tree represents the old architecture, and then the vines represent the new, where you are slowly replacing the old architecture with the new one. Blackboard Incorporated is a prime example. They are a lot like Canvas, but they had this old code system that they desperately needed to switch over, and were able to do so using this pattern, just slowly making the changes until the old system was obsolete. In conclusion, we want to remember to create an architecture that allows for productivity, testability, safety, and effective feedback. The Strangler application pattern is critical to constantly evolving our architecture to maintain it, make sure it's updated, make sure we're not using outdated code, and holding on to ineffective and inefficient parts. And we want to build our architecture in such a way that it will be easier to evolve in the future.